All right, what's going on, everybody? Today we're going to be doing a LeetCode problem called reverse linked list. It's a classic. We're just going to be reversing a linked list. So we're given the head of a singly linked list. So that's basically just a pointer here to a list node. So looking at the struct list node, we basically have an integer value, which we can disregard for this problem. And then we have a pointer that's going to point to the next node in a potential list of nodes. Uh, so so here you can see this illustration I think is pretty helpful. So we have, this would be we'd have a pointer pointing to this list node pretty much, and then this list node is going to have a pointer pointing to the next one and so forth. And they just want us to basically uh, reverse all of these pointers the opposite direction such that the final element in the list they pass to us is the new head, and then all of the pointers just point the opposite direction, and then they want us to return a pointer to the head of the new reversed list. So, or really, I mean, it's the same nodes just in a reversed order. So, yes, let's whiteboard this first. So, there's a couple of variables we're going to need. So, we're going to need some pointers. So we're going to have a pointer here. I'll have boxes to indicate that these are pointers and not actual list nodes. So we need a pointer pointing to the previous list node. We need a pointer for the current node that we're on. We can actually just recycle the head node or the head pointer to that they give to us as a function parameter. So we'll use that for the current node just to save a little bit of space to optimize that space complexity just a little bit more. We're also going to use a pointer for the next node um, to keep track of the next node in the list, and I'll show you exactly how those are going to be used here. So I'm just going to go through an example of um, I'll just go through the example of reversing this entire list here. So we'll have three list nodes here. At first, the head pointer is going to be pointed to the head list node. So this is pretty much what we're working with first. Also, this final node here technically does have a pointer. It's just pointed to null. And these pointers are going to be pointed to something at first. Likewise, they're also going to be pointed to null at first. So to start this algorithm, there's basically going to be 4 steps with each iteration of the loop. So the first step is going to be to point this next pointer to whatever the next list node is, because if we were to just reverse this pointer straight away without any extra variables here, notice, so I'll just do that as an example. I'll do the wrong thing first as an example. So this is wrong, this is what we don't want to do. If we do this, we're going to have a memory leak. We're going to lose the rest of the list. We'll never be able to access it again in the code. So we don't want to do that. We want to take advantage of what we have here. So we're going to use this next pointer. And instead of pointing that to null, we're going to set that now we're going to point that basically to whatever the next list node is. So whatever this list node, this head list node is pointing to next. So now we have access to the rest of the list. So that's going to be the first step. Now the second step is going to be now we can safely take this and point it the opposite direction. Um, Notice that, so we're going to be pointing this actually to whatever the previous node is pointing to. And it's null at first, but this is actually exactly what we want, right? Because uh, because this is going to be the new final node in the list. And notice how the final node in the list that was passed to us pointing to null. So this is perfect. So this is going to be pointed to null now, and this is good. So now we're going to take this previous pointer for the third step. So now we're going to move on to the third step. We're going to take this previous pointer and point it to whatever the head was pointing to, because we're going to want to basically move down the list to the next node. So again, to do that, we're just going to take whatever the head was pointing to and set that pointer there. And then for the fourth and final step of our loop, we're basically going to take this head node to continue moving down the list and point that to the whatever the next pointer is pointing to. So notice this. So this at this point we're done with the first iteration, and we can see that it looks like our list is broken up, and technically it is, but thanks to our pointer variables, we still have access to everything we're going to need. So it looks a little bit scary here, but this is completely fine. So we're going to move on to the next iteration of the loop. So again, the first thing is going to be to point this next pointer to whatever the head is pointing to next. So we'll erase this and then point this here to the next value. So now we have access to the rest of the nodes in the list. So we can safely take, for the second step, we can take this and then reverse it this way. So that's going to be pointing to whatever the previous pointer is pointing to. Uh, and then for the next two steps, the last two steps in this iteration, we need to just move the previous and the head again to keep moving down the list. So this will be set to whatever the head is pointing to. So we move that down, and then we set whatever the head is pointing to the next element. So finally, we're going to do one more iteration of this loop to basically finish off this test case. So the next pointer, notice how there's no more nodes here, but the next pointer can point to null. That's fine. So we're going to do that. So I'm going to erase what that's pointing to, and it's going to be pointing to whatever head is pointing to next, which is null. Okay, so now we can move what head is pointing to the previous, whatever the previous pointer is pointing to. So for that second step, so we can do this safely now. We go this way, and then we're going to do those last two steps where we slide the previous to what the head's pointing to, and then the head to what the next is pointing to. So I'm going to erase this. Previous will now be pointing to head, and then, or whatever head is pointing to, and then head will be pointed to whatever next is pointing to. And notice head is now pointing to null. We're basically going to, in our algorithm, we're going to be looping while head is not null. So now that head is null, we're done looping. And notice that the previous pointer is pointing to the, basically, this is going to be this was the final list node in the list that was passed to us. And it's now the new head of our reverse linked list, and the pointer that is giving us access to the reverse linked list is the previous list node pointer. So we're just going to return this pointer, and that's basically going to be the answer to the problem, and that'll finish that test case up. So for in terms of space and time complexity analysis, the time complexity is going to be big O of n. So, and that corresponds to the number of elements that are, or the number of nodes rather, that are in the list that was given to us. We're just going to be moving across that entire list one element at a time, thus giving us big O of n time, or linear time. And in terms of space complexity, we just have constant space because we're just going to be using these two list node pointer variables. And that's it for the space. So let's go ahead and get into the code. I think the code for this problem is pretty straightforward. So we're basically going to have those two list node pointers. So first of all, we're going to have the previous pointer. Both of these are going to be null pointer at first. So we also need the next pointer. I've seen some people use null like this instead of null pointer, but I think null pointer is actually a better idea here because for one, it's type safe, and I think for two, I think it's a little more clear to read when you're actually reading the code, because it's like it gives you an idea what the developer intended to do with these pointers when they were setting them to null. We know exactly what they were trying to do with them because we can see dealing with pointers here because we're using the null pointer keyword. So anyways, yeah, we're just going to use null pointer for that. And we want to loop while head is not equal to null pointer. But more concisely, we can just say while head. So while head basically um, isn't null. So while head is pointing to a list node, we want to set that next node or the next pointer to basically whatever the head node, which would be like our current node for the iteration, whatever that's pointing to next. So we're going to assign that next pointer to whatever head is pointing to next. And then basically, once we have the rest of the list preserved like that, we can reroute the whatever head is pointing to next. We can assign that back to the whatever the previous pointer is pointing to. So that'll reverse the direction of whatever that current list node is pointing to. And then we can move our pointer variables to move down the list. So the previous node will be pointed to whatever the head was pointing to, and then the head will be pointing to whatever the next pointer is pointing to. So that's pretty much it for the code. And then remember at the very end, our previous pointer is going to be pointing to the new head of the list. So we'll just return previous. And that's pretty much it for the code. So I'll go ahead and submit this. I'm not too worried about the percentages for this problem because I think most people have extremely similar solutions. So 26% for runtime, 15% with memory. I'll run it again just for fun. But anyways, I hope you guys enjoyed this video. If you did, and if it helped you understand better how to reverse a linked list, please leave a like and subscribe and all that stuff. So thanks, and I'll see you guys in the next video. Peace.